All right, so there is a relationship in a 45-45-90 triangle between the sides or the legs and the hypotenuse. In a 45-45-90 triangle, it is an isosceles right triangle. So I could label each of the sides or the legs as X, and the hypotenuse I can label as L. Now, if I were using Pythagorean theorem, which is the legs squared added together is equal to the hypotenuse squared, that would look like X squared plus X squared is equal to the hypotenuse squared. If I do a little simple algebra, this becomes 2x squared is equal to the hypotenuse squared. If I take the square root of both sides, that gives me that the square root of x squared is x, the square root of 2 I don't know, and the square root of h squared is h. So that tells me that h is the same thing as x radical 2. Now that's super helpful if I'm trying to solve some problems and all I have is one bit of information. So for example, if I know that one side of my right triangle, of my isosceles right triangle is 2, I have enough information to find the other two sides. This side down here is also 2. I know that h is equal to x radical 2, and since my x is actually 2 this time, it would just be 2 radical 2. Let's try another one. Let's say that I know that my isosceles right triangle has a hypotenuse of 7 radical 2. Now, by the same idea, I know that 7 radical 2 is equal to x radical 2. If I divide both sides by radical 2, I can cancel those out, and 7 is equal to x. Or you might be able to just look at this and say, well, that's got to be 7, because that was the only way it could be 7 radical 2. Now, there are some that are just a little bit trickier, and we do have to know a little bit about radicals in order to solve a problem. So let's look at one that's slightly more difficult. All right, on this one, we have our isosceles right triangle. Notice I don't have to put 45, 45, 90 in each of the triangle angles. I can just tell you that it's isosceles and right, and that gives me enough information. So now I need to find the other two missing sides. Well, one of the missing sides is really easy because it's congruent. So this guy is 3 radical 2. Now we know this guy, my hypotenuse, is equal to x radical 2. Well, in this case, my x is 3 radical 2 times radical 2. I have to remember how to multiply radicals. When we multiply radicals, we multiply the radicand, which is the number underneath the radical. So this is really h is equal to 3 times radical 4, because 2 times 2 is 4. Well, I know that 3 times radical 4 is really 3 times 2, so h would actually be equal to 6. Then there is the trickiest problem of them all, when I'm given the hypotenuse, but I'm given the hypotenuse in a whole number, so I can't easily find out what the x is. So I do use that same equation that we have above. So I know that h, or 8, is equal to x radical 2. So I'm going to do some math off to the side over here. I'm going to do 8 equals x radical 2. Now you can either divide by radical 2 on both sides, or we know if we multiply a radical by itself, we just get the radicand. For example, if I multiply radical 6 times radical 6, that's radical 36, or just 6. Or if I multiply radical 9 times radical 9, that's just radical 81, which is just 9. So when I multiply two radicals that are the same, I just get the radicand, or the number underneath. So if I multiplied both sides by radical 2, like this, then I would get 8 radical 2 over here, and on the right side, I would get radical 2 times radical 2 is just a 2x. Now I can divide by 4, and I get 4 radical 2 is equal to x. Bam. So that means that each of these missing sides is 4 radical 2. So this guy is 4 radical 2, and this guy is 4 radical 2.